All right. So chapter one, the way it's set up, is not really set up in a review type of fashion. I mean, it's set up more so like a review. It's not set up in a way that is going to talk about foundational stuff. Now, I do go back and do some foundational things, especially when we first start talking about equations. That's what I'm gonna do now. But my point is, if I miss anything that you feel like you don't understand where it came from, make sure you ask questions because there are going to be some assumptions when you go into the chapters when you even look at lectures. If I didn't mention it, there are some assumptions because remember, this is pre-calculus. So there are some things that they are expecting you to know or bring into this class. But if there's anything that you have a question on, feel free to ask. Also, don't forget, most of you are not letting me see you as far as the camera is concerned. That's fine for your lectures. But if I can't see you, that means I can't see if you're still writing. So you don't have to enable your camera, but just make sure you understand that if I scroll and I'm done with the statement, but you still need a copy and let me know so I can pause. Like I won't know if you don't tell me because your cameras aren't, enabled. Same thing with if you make a confused face but your camera's not enabled, there's no way for me to respond to that. So once again, make sure you let me know if you want me to either restate something, re-explain something, slow up, or pause right there because you're still copying. I will do whatever I can to accommodate you guys. All right. So 1.2, linear equations and rational expressions. So we're starting off with just solving equations. Let me erase some of this. So the equation is just a statement that two algebraic expressions, I don't know why I wrote that ESP like that, but two algebraic expressions are equal. So simple example of that is x plus 5 equal to 7. You know, so that's a simple example of that. X plus 5 is equal to 7. Just an algebraic statements, two algebraic statements that are stated to be equal. Now your solution will be value or values. You can have more than one solution depending on the complexity of your problem that will make an equation true. So in this case, x equal to 2 is going to be the solution for this equation. And then always remember you can plug it back into your original equation to see if it makes a true statement. So of course, 2 plus 5 is equal to 7. So whenever solving and you're looking at your equation, you should be asking yourself, when is this statement true? So in other words, when is x plus 5 equal to 7? And the answer is when x is equal to 2. So your goal is at all times when you're trying to find the solution, when is this statement that you have true? When is it going to be true? In this case, it's when x is equal to 2. All right, we will be solving by what I call opposite operations. In other words, they are operations that undo what the other one does. Addition and subtraction are opposite operations. Multiplication and division, opposite operations. They undo what the other one does. And when we get into more complex equations, we'll keep on that same type of thought process. Just like a square and square root will be opposite. They will undo what the other one does. So when we look to solve, let's go back to the one that we just had. X plus 5 equals 7. Of course, it's easy to see that 2 plus 5 is equal to 7. But when you're talking about the foundation of what you will be doing, your goal is to get x by itself. So you want to undo what's being done to x. So if you have x plus 5, then you want to use the opposite operation to undo the addition of 5, which means you will subtract 5. Now, your equation is split up into two sides, left side of your equal sign and right side of your equal sign. In order to keep your equivalency, whatever you do to the left side of your equal sign, you have to do to the right. So if I have minus 5 on the left, that means I need to minus 5 on the right. So 5s on the left will cancel, and that will leave me with just x. And then on the right, 7 minus 5 is 2. And there goes my solution of x equal to 2. So that's the foundation of what you'll be doing when it comes to solving equations. Your goal is to get x or whatever your variable is by itself, and you're undoing what's being done to that variable in order to get it by itself. I'm just erasing these so we can do them from scratch. So a few more one-step equations before we add more to it. Y minus 10 equal to 15. We have a minus 10 that's being applied to the y, so that means we want to add 10 to both sides of the equation. Y equal to 25. The 10's cancel. Over here, 5a equal to 13. 5a is 5 times a. So if I have 5 times a, that means I need to divide by 5 on both sides. A is equal to 13 over 5. Notice I didn't divide 5 into the 13 or turn it into a mixed number. So I didn't convert to a mixed number or convert it to a decimal. It's not necessary. But what you are expected to do is to reduce. So when we talk about down here, if I have 4 over 6, that is expected to be reduced down to 2/3 because 2 can divide into both of them evenly. That is expected. They will not ask you to do that. They expect you to do that. Now the 13 over 5, that cannot reduce. So dividing it into 13 or converting to a mixed number is not the same thing as reducing. That's just converting it to a mixed number or converting it to a decimal. This right here is considered reducing your fraction or simplifying your fraction. So that is expected of you. This is okay to leave as is. So just making sure we're okay with what is expected of you and what's not necessarily. All right, last one like this. We have x divided by 9. In order to get rid of the division of 9, we will multiply both sides by 9. Once again, the opposite operation. 9's cancel, leave you with x, and then 11 times 9 is 99. And that will be your answer. So before we add more to it, any questions on these one-step equations? All right. So let me erase some stuff. All right. So here we have 2x plus 1 equal to 17. Notice we have more than one operation being applied to x. We have 2 times x plus 1. So the best way to handle this is to move the number or the term that's furthest away from x versus the one that's right up against it. So in other words, I would look to subtract 1 from both sides first. Now you can divide by 2 first, but it would not set you up the best way because you have to divide each term of both sides, in other words, by 2, and now you're setting up fractions for yourself, and most people don't want to deal with fractions if they don't have to. So the first move, the most efficient move, is to subtract 1 from both sides. Subtracting 1 from both sides will cancel out 1 on the left, would give us just 2x, and then 17 minus 1 would be 16. Now to finish it off, we divide both sides by 2, and 2's cancel and leaves us with x equal to 8. And remember, you always can check by taking the 8, plugging it back into your original equation. 2 times 8 is 16 plus 1 is 17. So that would always, or that should always work for you. All right. Next one. Well, anyway, I'll just start right here. We have 2 times the quantity of x minus 3 minus 17 equal to 13 minus 3 times the quantity of x plus 2. All right, so we want to distribute first because we need access to those variables, and those parentheses prevent us from getting to those variables. So we'll distribute 2. And then here, we're not just distributing 3, but we're distributing -3. So don't forget that sometimes people will distribute 3, but not distribute a negative that comes along with 3. That will leave us with 2x minus 6 minus 17 equal to 13 minus 3x minus 6. Now, at this point, what I would do is before I go across my equal sign, I would simplify as much as possible on this side, simplify as much as possible on this side, like I said, before I go moving terms across the equal sign. So now I have -6 and -17, which will give me this -23. 3 and -6 gives me this 7. I just combine like terms on each side of our equation. Also, I pointed out last class, you have 7 minus 3x on the right. If you wrote -3x plus 7, that's the same thing. As long as your 3x is negative and your 7 is positive, you still have the same expression. All right. So now we have 2x minus 23 equal to 7 minus 3x. So now your goal should be to get all of your terms with x to one side, all of your terms without x to the other. We have 4 different terms here: 2x, -23, 7, -33x. It does not matter which term you move first. As long as you do everything correctly mathematically, you will still get the same answer. All right, so we have a question in the chat: is converting and reducing only for fractions, or does it apply to numbers as well? You always want to write the most reduced answer possible, the simplest answer possible. So if my solution ended up being 6/2, then you are expected to write that as 3, because 6 divided by 2 is 3. Let's say if I had, what's another good one? You know, but if I had 17/2, 17/2 is just 17/2. Yeah, so you're always expected to reduce your fraction as much as possible. If I have 4x squared over x, that reduces down to 4x. Yeah, whenever you have an expression or a solution, you are expected to reduce it down as much as possible. Did that answer your question? I want to make sure I answered your question. You know, always just type in the chat, and I'll look for it. So here, I decided to go ahead and move the 3x. Once again, it doesn't matter which you decide to move first. You still get the same answer if you do everything correctly. 3x cancels. That leaves me with it leaves me with 5x. So it'll be 5x minus 23 equal to 7. Somebody in the chat. Okay, cool. All right, great. So now we have 5x minus 23 equal to 7. Now that I got or have all of my x terms on one side, I have a single x term. I can now move the 23, add 23 to both sides. 23's cancel. And from there, I would have 5x equal to 30. Then you can finish it off by dividing both sides by 5. 5's cancel, and x is equal to 6. All right. Is everybody okay? Everybody good, okay. All right, so the next one, we have 5x minus the quantity of 2x minus 10 equal to 35. Distribute the negative, because once again, we need access to the x. Cannot get to the x until we remove what's sitting in front of the parentheses and holding that parentheses there, and that would be that negative. So now we have 5x minus 2x plus 10 equal to 35. Combine your like terms. 5x minus 2x, they're on the same side of the equation, so we just go ahead and combine them, and that'll be 3x plus 10 equal to 35. All right, now subtract 10 from both sides. 10's cancel on the left, leaving you with 3x. And then 35 minus 10 is 25. So we have 3x equal to 25. Divide by 3. Threes cancel, and your solution is 25 over 3. Any questions? Any questions?
I might have lost track. So at the top you have the two arrows. Are you saying like you're distributing the negative sign or?
Yes.
Okay.
Yep, that's exactly what happened. In the same fashion as if I had a number sitting out there, you can distribute that negative. And all it does is it changes the sign of each term that was inside of the parentheses.
Okay, thank you.
All right. Questions? Everybody good? Okay, so let's go to the next one. So here we have an equation that involves fractions. X plus 2 over 4 minus x minus 1 over 3 equal to 2. And so most people, as mentioned before, don't like to deal with fractions if they don't have to. So what we're going to do is call clearing out the fractions. First thing we're going to do is find our LCD. Hold on, see somebody in the chat. And want to join the call. Oh yeah, that's fine. Okay. So we're going to clear out the fractions. First thing we're going to do is find the LCD. And the LCD, yep, somebody said the LCD is 12. Thank you very much. Yep, the LCD is 12 in this case. Remember, your LCD is always going to be the smallest number that each denominator can divide into evenly. So we have 4 and 3. And so 12 is the smallest number that 4 and 3 can divide into evenly. So also want to keep in mind, let's say if you found a number that was larger than 12, let's say 24. That's fine. Just remember 4 and 3 has to be able to divide into them evenly in order for this process to be successful. If you use 24, that's fine. You'll just end up using bigger numbers than the 12 will produce, but you still will get the same result at the end. The main thing is that you want a number that 4 and 3 can divide into evenly. All right? Because the next step is going to call for us to multiply each numerator by the LCD. And that's what we did here in step 2. 12 times x plus 2 over 4 minus 12 times x minus 1 over 3 equal to 12 times 2. And that one in the back, that 12 times 2 is big. A lot of people forget that, because they assume because it doesn't have a denominator, then they don't multiply it times the 12. That's not the case. You have to multiply each term. Each expression has to be affected by that LCD multiplication, or you're changing the value of the equation. So everything is being multiplied by the LCD. All right, any questions on the process so far? Yes, sir.
When we multiply there's a negative in front of the 12. We don't turn that 12 into a negative, right? That just stays 12. And after, when we're simplifying it, that's when the negative comes into play.
Well, the way I do it is I go ahead and distribute it when I distribute my 12, just because it was a part of the process. At some point, it has to be a part of your distribution process.
Okay.
So instead of distributing, distributing the 12 now and then distributing the negative later, I just go ahead and attach it to my 12.
Attach it right.
Yep, and that's a great question because a lot of people forget that negative, and a lot of times they give it to just the first term. They'll just give it to the x and not give it to the one that's in the parentheses. So that's a great question to point out. That minus sign, that's what we're going to do next. Well, that will be what we do in step 3 when we do our distribution. But we most definitely want to make sure at some point that minus sign is distributed to each term in that parentheses. Got somebody in the chat? Okay. So now when you talk about finding the LCD, there are a couple different ways that you can do so. You can go through the multiples of 4 and 3. 4 times 1 is 4, 4 times 2 is 2, 4 times 3 is 12, then 3 times, you can do it that way. You can just multiply both of them together. That may not be always the LCD, but it will be something that both of them can divide into evenly. And then there's another process that, involves their prime factorization. So I can talk to you about that maybe offline because that takes more of a process. But one of the safest ways is just to multiply both of them together. 4 times 3 is 12. And like I said, that thought process will not always produce the LCD, but it will give you a number that both of them can divide into evenly. Case in point, let's say if this 3 was a 6, 4 times 6 is 24. that is a number that 4 and 6 can divide into evenly, and you can use it. But the LCD would actually be 12. You know what I'm saying? So it's all about which way you want to go. If you want to know about the other process, you can always shoot me that email, and we can talk about it offline. Oh, this was a 3. And also with that, I don't know if I mentioned to you guys, on my YouTube channel, you know, you guys have YouTube links, but on that channel, I have all types of videos because I've done, you know, developmental classes last semester, different type of contemporary mathematics classes where I talk about factoring, talk about LCDs, all that stuff. So if you just want videos to reinforce that, you can always shoot me an email and I can shoot you that. Or if we need to meet in a separate Zoom, you know, I talked about office hours, we can do that as well. So just throwing it out there, I have a couple different ways that I could help you out as far as reassuring, whether it be stuff like LCDs, factoring, or whatever the case may be, things that this book would expect you to already have, you know, come across, you know, before jumping into the chapter. So I know that everybody's not, you know, doing math whenever they get a chance, just to make sure their whole, you know, so it's all good. So don't feel ashamed, don't feel bad. Just hit me up and we will make sure that you're straight. All right. Yep, not a problem, not a problem. So now for step 2, we multiply each numerator by the LCD. Now we're going to simplify. That 4 can divide into the 12. Remember, that was the reason why we used that number. 4 can divide into 12, leave you with 3. 3 can divide into 12 and leave you with 4. And now those denominators are completely gone. And that leaves us with 3 times x plus 2 minus 4 times x minus 1 equal to 24. All right. From there, we can go ahead and solve. Distribute 3. Distribute negative 4. The result would be 3x minus 6 minus 4x plus 4 equal to 24. Combine your like terms. We have 3x minus 4x, which is negative 1x. 6 plus 4 is positive 10. And the 24 is still over there by itself. Now we can solve for x by subtracting 10 from both sides. Negative 10 cancels. Negative 10 and positive 10 cancels, leaving us with negative x equal to 14. And don't forget, our goal is to solve for x, not negative x. So we can take that minus sign and shoot it over to the right. And our result is going to be x equal to negative 14. All right, somebody in the chat. 10 came from the addition of 6 and 4. All right, 6 plus 4 gave us that 10 initially. All right, anything else, anybody else before we look at the next example?
I think there was a question in the chat.
Oh, there's another one. I missed it. Okay, yeah. That's what he asked, where did the 10 come from? How do you find the LCD? Yeah, we talked about that. Yeah, okay, yeah, we should be good. All right, so next one. Rational equations. So whenever we have our fractions, normally when you talk about fractions and equations, those are considered rational, but most definitely when you involve a variable in your denominator. So when you involve a variable in your denominator, that's most definitely when they lean towards the idea of it being a rational equation. So the first thing, just like we did before, if we have fractions involved and we want to get rid of our denominator, clear out our fractions, the first thing you want to find is the LCD. So notice our denominators, x, 5, and 2x. And we need the smallest expression that each one of those three can go into evenly. Well, the smallest number that 5 and 2 can divide into evenly is 10. And then you see we have x. We don't have x squared, we have x. So x can divide into itself. So that's why we have 10x as our LCD. All right. So now what we're going to do, and if we're talking about our steps, this is step 1, find the LCD. Step 2, multiply each numerator by that LCD. So 10x times 1, in that first one, 10x times 1, in the second one, and then 10x times 3 in that third expression. Our denominators are staying the same. Remember, we're not affecting the denominators. We want to get rid of them. So we're multiplying across the equation. Each term of the equation, multiplying the numerator. So what that does, it allows x to cancel in our first expression. 5 divides into 10, leaves you with 2. 2 divides into 10, leave you with 5. And then x's cancel. So step 3, we simplified, and then we coming over here. So what we should be left with is 10 times 1, which is 10, 2x, and then plus 15, 5 times 3. So before we go any further, make sure we're okay with what happened. Found our LCD, which was 10x. That was the smallest expression that 5x and 2x could divide into evenly. Multiply each term by that 10x. So x canceled in the first expression, 5 divided into the 10, left you with 2 in the second expression. 2x canceled into 10x and left you with just 5. So it left us with 10 times 1, which is 10, 2x times 1, which is 2x, and then 5 times 3 is 15. Now I can solve this the same way we've been solving our other equations that didn't involve fractions. I will subtract 15 from both sides. And that'll be negative 5 equal to 2x. And so 2x equal to negative 5. Go ahead and divide by 2. 2's cancel and leaves us with negative 5 over 2 as our answer. All right, questions, any questions? All right, next one. We're looking at x over x minus 3 equal to 3 over x minus 3 plus 9. So our only denominator that we're dealing with is x minus 3, so that would be our LCD. All right. So follow the same process, same procedure. Once you find the LCD, you multiply each numerator by the LCD, whether it has a denominator or not. So that's x minus 3 times x over x minus 3, x minus 3 times 3 over x minus 3, and then x minus 3 times 9. All right, x minus 3's cancel, x minus 3's cancel, and then what we're going to do is distribute this 9 into the parentheses. So that'll leave us with just x in the first expression, then 3 from the second expression. And then after our distribution of 9, that'll be 9x minus 27. Now we can combine our like terms. We have 3 and negative 27. It comes down to give us negative 24. So to give us x equal to 9x minus 24. We want to get all of our terms with x to one side of the equation, so we will minus 9x from both sides. 9x cancels, and that leaves us negative 8x on the left equal to negative 24. And so now we'll finish it off by dividing by that negative 8 to get x by itself. Negative 8's cancel, leaving you x equal to 3. All right, so remember I said that you can always check your answer by plugging it back into your original equation, and we may not always opt to do that, but whenever you have a rational expression, well, let me say this, there will be some problems that we come across, and we'll talk about them soon, that you have to go back and check them, because even if you did everything correct, they still will not necessarily produce the right answer every single time because of certain things that we have to do to manipulate the problem. So, you could have two answers, one of them right and one of them wrong. And so we'll talk about that as we progress forward. This one, though, even if you decide not to plug the 3 into the whole equation, you still need to at least check your denominators. So what I mean by that is that when you remember our original equation was x over x minus 3 equal to 3 over x minus 3 plus 9. So if I were to plug 3 in where I see x, that would be 3 over 3 minus 3 equal to 3 over 3 minus 3 plus 9. 3 minus 3, of course, is 0. That gives me 0 in my denominator. Even if I didn't have this plus 9 right here, 3 over 0 equals 3 over 0 still is incorrect because I have 0 in my denominator. Remember, 0 in your denominator is always undefined. So let me put this plus 9 back. So what happens here, we have these statements that takes us into the closing of this problem. Since x is equal to 3, since x is equal to 3 produces 0 in the denominator, we cannot use it. That means x equal to 3 is extraneous. That's what it means when you come up with a solution that you cannot use, extraneous. So since x is equal to 3 is our only option for a solution, this means the answer is actually no solution. And so what I mean by that is that, let's say if we had two solutions, x equal to 5 and x equal to 3, found out that x equal to 3 was extraneous, I can still use x equal to 5. But in this case, I didn't have another solution other than x equal to 3. Since I cannot use x equal to 3, the answer is no solution. All right. Questions on that? Questions before we go any further? All right, scroll up. Good, good, good. All right, so the next one. This one has more involved denominators, but the process is still the same. We want to find the LCD first. And notice we have x plus 6, x minus 2, and then x squared plus 4x minus 12 as our third denominator. Now, when you factor that third denominator, that actually gives us x plus 6 times x minus 2. So since x plus 6, x minus 2 is a part of each denominator, then that would actually be our LCD. Now let's say we had x minus 5 over here in this first numerator, then that means x minus 5 needs to be a part of our denominator, our least common denominator as well. So each quantity that you see needs to be a part of your LCD, okay? You don't have to repeat any unless you see a different power. I don't think you guys are going to come across that in this section, so we don't have to worry about it. But each quantity that you see needs to be a part of your LCD. So we have x plus 6, x minus 2, and then in the third one, after we factor it, is x plus 2, x minus 6. Once again, going back to, different things they are expecting you to have dealt with before coming to this class. If you have any issues with factoring, let me know. I can shoot you a couple of YouTube links that I talked about factoring, or if we need to sit in a Zoom session, like I said, shoot me that email so we can talk about it. All right. So now, once you've established your LCD, you're going to multiply each numerator by the LCD. Remember, our numerator is 3, 1, and 4. So that's what we did here. We multiply x plus 6. Let me move these lines. I don't want to cancel yet. I'm going to talk about it. So I multiply each numerator by x plus 6 times x minus 2. So we have 3 times x plus 6, x minus 2, 1 times x plus 6, x minus 2, and then 4 times x plus 6, x minus 2. Did not change the denominator in either case. So now we see, but I did rewrite this one in its factor form. That will help us with our cancellation. We see x plus 6 will cancel, x minus 2 will cancel, then here x plus 6 and x minus 2 cancels. And that leaves us with this expression down bottom, which is 3 times x minus 2 plus 1 times x plus 6 equal to 4. Questions before we go to the next step? All right, distribute. So 3 times x is 3x, 3 times 2 is negative 6. And of course, 1 times anything is itself. Now we can combine the like terms. 3x and 1x is 4x. And then actually negative 6 and positive 6 will cancel out, leaving us with 4x equal to 4. Then we can finish it off. 4x over 4 equal to 4 over 4. Divided both sides by 4, and our final answer is x equal to 1. Question, I think we got a few more. Yep, got a couple more left. Questions on that one. And so going back to what I mentioned as far as checking is concerned, x equal to 1 would not produce 0 in your denominators. 1 plus 6 is 7, 1 plus negative 2 is negative 1, and same thing with the trinomial. But if you were to plug 1 into the whole thing, you should get a true statement. All right. So let's go to this next one. And I will, let's see, I erase all this. All right, so we have 2 times x plus 1 equal to 2x plus 3. First thing we want to do, and we have a special scenario that's going to happen with this, so I won't erase what's in blue. First thing we want to do is distribute the 2. That will give us 2x plus 2 equal to 2x plus 3. Now to solve, I will subtract 2x from both sides. So 2x minus 2x will cancel. And so the special thing about this one is that a lot of times people are afraid to let math happen. And what I mean by that is that they will let 2x and 2x cancel on the left and write 2, but then on the right, they will write x plus 3. But you can't do that. If 2x minus 2x cancels on the left, then 2x minus 2x also cancels on the right. So really the statement that you're left with is 2 equal to 3. And 2 equal to 3 is false. Of course, that's a false statement. That's not true. So the scenarios that has occurred, your variables canceled out. You have a false statement. Whenever your variables cancel out completely and you're left with a false statement, your answer is no solution. So notice I didn't mention that you variables cancel and your answer was 2 equal to 3. Because in this case, let's say if you decided to subtract 3 first, then you would have ended up with -1 equal to 0, or it could have been 0 equal to 1 if you subtracted 2. So it's all about getting a false statement because each one of these statements are still false. 0 is not equal to 1. So once again, just across the board, if your variables cancel out completely and you end up with a false statement, your answer is not false. You end up with a false statement, your answer is no solution. All right. Any questions on that? So next one is very similar. Here we have 4x plus 6 equal to 6 times the quantity of x plus 1 minus 2x. Distribute 6. 4x plus 6 equal to 6x plus 6 minus 2x. Combine your like terms on the right. We have 6x and negative 2x, which will give us 4x. So now we will have 4x plus 6 equal to 4x plus 6. If I subtract 4x from both sides, 4x is canceled, leaving me with 6 equal to 6, or depending on the order that you did it, you could have 0 equal to 0, which is a true statement. So this time we have a true statement instead of a false statement. Variables canceled. We have a true statement. Our answer will be all real numbers. All right. Questions. All right. So in that last one, no solution, that means there's nothing I can plug in for the variable, nothing I can plug in for x to make that a true statement. Here, all real numbers, that means I can plug in anything and it will be a solution. Yes, sir.
So when 6 equals 6, it's a true solution. Let's say it's 14 equals 14. That's a true solution. But when they're not equal to each other, that's when it's a false statement.
Right.
Okay.
Right. And so going back there, because I know people have made this mistake in the past, once you get the statement of false or true, you don't write false or true. The result is, if it's false, your actual answer is no solution. If it's true, your answer is all real numbers. Yep. Anybody else? Anything else? All right. So that is it for 1.2. We got a few minutes left. I'm not going to do 1.3 today because I know some people still need to get acclimated and get into my math lab, get registered. I know a few people had some questions, so I'm going to take care of that. So that being said, if you're done with me or you're good to go, in other words, have a great weekend. Be safe. That's 1.2. You can always check out 1.2, and the best way to handle class is do your best to try to keep up with the lectures. How I lecture is your gauge. So in other words, if I'm in 1.8, but you're still in 1.4, then you know you need to get caught up. Because at some point we're going to be done with chapter 1 and the test is going to be expected. You know what I mean? So you always want to make sure you're close to where the lectures are. And you know, we'll go from there. And if you have any questions on anything, always feel free to ask questions on where you stand and all that. Feel free to ask. Mr. Coley, you unmuted. You have a question?
Nah, I got this high-tech calculator from the syllabus. I got to figure out how to use
it. Well, you know how to get in contact with me, sir.
I got to go to YouTube, right?
Well, yeah, you can. But if there's any doubt, you know, feel free to contact me, and I'll do whatever I can to help you out on that front.
Point and all that stuff.
Anything else? Anybody else before we close out?
I'm the old dinosaur in the class. Sorry, folks.
You're all good, man. What you got, sir?
I wasn't able to get into Pearson. I have an account. changed my password. That's not working. And then it said error message because
Oh, okay, so that happened to me too. So what I had to do, I contacted Pearson and they told me to make a whole new account. But like I had to use, if you don't have, like if you have a regular email, you can use that. That's what I had to do.
so I'll use my because I used my TCC email for my older account.
That's what I had for my old account, and they can't fix it. So you have to make a new account with your like regular non-school email.
That's what I had to do too.
But we can still use the code, right, to get
Yeah.
into the Pearson class, Mr. Tucker's
Mhm.
code. Okay. Mr. Tucker, I'm gonna do that right after class. And where can I find your email? I was trying to find your email. I can't find it anymore.
Okay. So it's B Tucker
Okay, hold on.
at TCC. Thank you, classmates, Miss Ashley and Miss, is that Catalina? How you say that? Thank you for that. So it's just B Tucker at tcc.edu. Also, you can contact me through Canvas. If you send me a message through Canvas, it'll go to my email as well.
Okay, so I'm gonna do this right after class, and if I can't get in, I'll shoot you an email. And so let's see if we can figure this out.
All right,
So I
sounds
can
good,
start
sir.
the homework.
All right, sounds good. Thank you.
All right.
Mhm. All right, anybody else? Any questions, concerns? Everybody's good to go?
Yeah, talking about a calculator, we need one for this class, correct?
It's just not necessarily. I know a lot of people, it will help you, it wouldn't hurt. Now are you taking 162?
Well,
The reason why I say that, the reason why I say that is that it's not a bad investment to go ahead and get it now, because I know you will be doing trig in 162, and so you'll need a calculator then. So it would be good to go ahead and get it now, and then you'll be acclimated to it by the time you get to 162. You know what I mean?
Perfect. And where's the best place to get it? To get
Oh
one?
man, you can just go to Walmart. I mean, they used to be hard to find. Now they're just everywhere now. Now it depends on what type of calculator you want. Now, if you want a graphing calculator, they're more on the expensive side. Really, all you need is a scientific one. As long as you can, use sine, cosine, and trig. The better ones are the ones that you can actually, when you type into the calculator, actually have, a process, put in parentheses, divide, where you can write out the actual process versus saying, okay, now what I have to do is do 5 plus 3, then I have to write it down. You know what I mean? When you don't have to type out all the steps, you can just put them all in your calculator. Those are the best calculators, and those aren't, as expensive as they used to be. They're about $30.
Okay, cool. Thank you. I appreciate it.
Not a problem. All right, anybody else? Anybody? And like I said, calculator is not necessarily mandatory, but you will need that in 162 when you start dealing with trig. So if you plan on taking 162, let me see. On PC, the Windows 10 calculator has a scientific calculator option. Click the 3 lines at the top. So one of your classmates mentioned how your Windows 10 calculator has that scientific calculator option. So that's cool. That's cool. All right. Anybody else? Everybody straight before we close out? Are they good? I think most people have left. That is all good. All right. So you guys have a great weekend. Be safe. Don't forget, I won't see you again until Wednesday. And we'll jump into 1.3. And if you have any other questions, make sure you let me know. You
And we
guys
have
have a
homework
great weekend.
for this 1.2, right? We have
Say that one more
homework.
time.
We have homework for this 1.2.
Yes, it's in my math lab.
Okay, perfect. Thank you.
Yep, no problem. All right, you guys have a good one.
Thank you. Have a good
Thank you. You too. Have a
weekend.
good one.
Thank you. You the same.
So.
Take care.